Right, let's make a start. So just to let everyone know before we start, if you could please keep your mics and cameras off during the webinar. If you can do questions in the chat, please, and there's a couple of Q&A sessions planned for the webinar, so questions in the chat and we'll get to them later. And finally, this session is being recorded, as you'll have been notified, so please be aware of that. Thanks. So, welcome everyone to the Weave Smart Meter Data Unlocked webinar. My name is Richard Snape. I work for the Energy Systems Catapult, and we're hosting this webinar on behalf of CEMEA and CAKE, the Centre for AI and Climate. I'm a senior modelling consultant here at the Catapult, and also quite relevant to this webinar, I'm the co-director of the newly funded Smart Energy Data Service, or SENSE, where we're aiming to provide smart data for research in the energy community. I'm going to be moderating and chairing the webinar today, but I won't speak for too long. Just to give you an idea what to expect from the webinar today, we're broadly going to do this in 3 half-hour sessions. We're going to have half an hour on the Weave platform itself and the project that led up to it, half an hour of a panel session later, and then half an hour of general Q&A. I'll introduce people as they start to speak, but we'll start now with a piece from Steph King from CEMEA, who is the Director of AI Initiatives there, and is going to talk to us about the context and genesis of the project. Can I hand over to you, Steph?
Thank you so much, Richard, for the warm welcome. And thank you to the Energy Systems Catapult for hosting us and providing this platform for discussion today. So my name is Stephanie King. I am the Director of AI Initiatives at CEMEA, which, while it's a French acronym, translates to the International Center of Expertise in Montreal on Artificial Intelligence. CEMEA is a nonprofit organization based, obviously, in Montreal, Quebec, Canada, that was created to play a leading role in the international ecosystem towards the development of responsible AI, which for us means AI that is based on principles of ethics, human rights, inclusion, diversity, innovation, and economic growth. Tangibly, we do this through the implementation of applied AI projects, one of which you'll be hearing about today. So I'll keep my intervention quite short, as I'm just as excited as all of you to dive into the presentations and discussion around this work. However, first, I would like to provide a short background for how this project came to be. And so the work you'll see today originated from our climate change and AI roadmap that we published back in 2021, which was through our project support to the Global Partnership on AI. Together with UK-based Centre for AI and Climate, also with Climate Change AI, and with a host of global experts who contributed to the report, we noted 48 distinct recommendations for governments intending to help guide their actions on how to support responsible adoption of AI for climate action. So specifically, this project addresses 2 of those key recommendations. The first, to rapidly create data portals to increase data access and sharing. And the second, collaborate to fund the development of spaces for open source, climate relevant data models and/or softwares. And so we're incredibly thankful to both Canada and the United Kingdom for having agreed to partner and support the creation of this project back in 2022, first announced at the GPACE Summit in Tokyo. It's these types of international collaborations that allow us to connect, bringing together different perspectives, backgrounds, expertise, and research interests to propel us further than we could have gone on our own, something that is especially important when dealing with global challenges that require global action. And so CEMEA is quite proud of how the project has evolved over the past few years, and wish to extend our sincerest thanks and appreciation to everyone involved, particularly the brilliant team that Pete has put together at the Center for AI and Climate, who he'll introduce shortly in the next block, as well as our supporting team at CEMEA and the valued members of our strategic advisory and governance groups for what they have collectively delivered. The governance group, just a brief introduction to these individuals. So the governance group oversaw the delivery of the project, was made up of myself, my colleague Stefan Janusz, who's a senior project manager at CEMEA, Peter Klottenbrock from the Centre of AI and Climate, and Mario Rivero-Huget, Head of Science and Technology at the British High Commission in Ottawa. Our strategic advisory group, who advised on the direction of the project consisted of Stephen Haven at the Energy Systems Catapult, Pascal Lesage at Environment and Climate Change Canada, Robin Lucas from Modo Energy, Denilson Barbosa at the University of Alberta, and Dan Travers at Open Climate Fix. And so we thank all of them for their advice and commitment. At CMEA, we see Weave as a much needed practical step towards the long stated ambition to use AI to help achieve net zero. And so with that, I'll hand it over to Pete to start the official session. Thank you very much and enjoy.
Thank you very much, Stephanie. And just to echo Stephanie's thanks to everyone involved in the project. It's been a pleasure to work on this, and especially thanks to CMEA, our partners who are involved in this project. I also want to thank the UK government, especially the Department for Science, Innovation and Technology, who funded the development of this project and allowed us to build what we ended up building. So thank you for them. Maybe just to introduce myself, I'm Pete Cluttenbrock. I'm the Executive Director of the Centre for AI and Climate. Our organization is really focused on advancing the application of data science and AI to accelerate action on climate change. And specifically, we work to make it easier for data scientists applying AI to climate challenges to access machine learning ready data sets. So this is what we do as an organization. Next slide, please. So the context for this particular project has been that the UK government has very kindly funded this project, and that funding sits within a wider picture of government support, both for the development of the transition to net zero energy in the UK and for the support for AI, the development of AI and its use cases in the UK as well. On net zero energy, we've had really strong policy signals in the UK, especially more recently via the Clean Power 2030 goal, which is really redefining and shaping pretty much all policy in the energy space towards achieving that goal of meeting 100% of electricity demand with clean power by 2030. And it's really important that support for that goal has come down from the very top. On the AI side of things, more recently, we've had the AI Opportunities Action Plan, which has set out a goal to unlock data assets in both the private and public sector. It's actually done a wide range of other things as well to support the infrastructure and human capacity needed to enable the UK to become a leader in AI. But specifically, it's made really good progress around thinking about how to unlock data assets that are really critical.
Just 1 second, Pete. You seem to have become muted. Can you just unmute yourself?
I can. Can we go back just a slide? John, can we go back a slide? Thank you.
Back now.
Okay. Yeah, so we're seeing really good support for the provision of better data by the government from across the space. So we're seeing the combination of both support for the transition to net zero and the support for development of AI, which has really enabled these kind of projects to come forward and provide the value that they do. Next slide, please. So within the energy sector specifically, obviously the application of AI is really important to enable the sector to become more efficient, but actually there's a stronger and wider rationale for open energy data. And that is, as part of the transition to net zero, the electricity system is becoming super complex and much more interconnected, with many more interactions between generation, storage, consumption, and the grid operations of the networks themselves. And all of these different factors end up influencing each other because it's a very much an interconnected system. And so to enable much better decisions, we really need each actor of those in those different parts of the system needs to understand what everyone else is doing. And that is really key to unlocking a whole range of things. Specifically, it allows innovators to develop new tools, services, and insights to optimize the system. It allows specific actors across the system, such as the electricity network operators or policymakers, to coordinate actions across the system. And as I've said, it's really fundamental to allowing the adoption of AI to support things like system forecasting and real-time optimization, which is where we feel like the value of AI really lies in terms of the energy sector. Next slide, please. Within the energy sector and within energy sector data, there is one particular subset of data that we've focused in on, and that is understanding electricity demand because we feel that that's increasingly important to enabling a zero-emission electricity system. Now, John's going to go into that in a little bit more detail, but key to understanding electricity demand is getting access, enabling better access to smart meter data, which is really a fundamental part of understanding demand across its geographical contexts. And the reason why understanding demand and specifically smart meter data is important is that it unlocks a whole series of opportunities to innovate across the sector. So it enables greater system efficiency and grid planning. So if you're an electricity network operator, there's a whole range of different ways that you can start using smart meter data to improve forecasting, to guide upgrades, to support the planning of asset rollouts, such as how you respond to the development of EV charging and heat pumps at different levels of the network. It then enables a whole range of different solutions to come through by accelerating innovation and system flexibility. So we see it helping organizations trial new approaches to flexibility and automation, whether it's new tariffs or whatever. It enables better forecasting and control of assets in real time to allow for the assets to be used in a much more efficient way. And we see a whole range of different experimentation going on from energy suppliers to explore different kinds of tariff design and energy services, all of which are underpinned and unlocked by better smart meter data. And finally, the provision of understanding where the better data on smart meter comes from enables better policy making and decision making from government and the regulator as well. So more targeted policies based on actual usage of different network assets, the ability to monitor the impact of interventions and behaviors, and support for transparent research and system-wide learning. So we think good access to smart meter data is increasingly important across the system. Next slide. So finally, if we think smart meter data is important, what is the current status of access to smart meter data? At the moment, there are over 30 million UK homes and businesses who have smart meters, but access to this data is somewhat complicated. So we have the access that currently is mainly managed by the DCC, the Data Communications Company, which acts as a hub for smart meter data in the UK. At the moment, access is really only granted for authorized users under fairly strict conditions, and becoming such a user is not necessarily easy for any kind of developer who's wanting to experiment to do. More recently, we've seen the network operators, the distribution network operators in particular, the DNOs, start to publish aggregated smart meter data, not necessarily at the individual meter level, but aggregated to ensure privacy. But the format varies a little bit across the different networks and isn't always necessarily appropriate for machine learning applications. So that's the current status of the project when we started looking at things. So we saw an opportunity to really dig into this and explore how we could make things better. So I'm going to hand over to John now to talk a little bit more in more detail about the specifics about what Weave is and what we're hoping to build and what we actually did build. Over to you, John.
Cheers, Pete. Hi, everyone. So I'm John. I'm the product lead at the Centre for High and Climate, working specifically on Weave. So today I'm going to give just a brief overview of the Weave project from the kind of research phase and what we learned through to the solution and how and why we built it. I'll then hand over to Steve, who's our engineering lead, who will give you a bit of a deep dive into the technical aspects of how the product works. And then I'll pop back at the end to talk about the community aspect of Weave, kind of some real world applications and how you can get involved. So yeah, at the beginning we had a fairly brief kind of research and discovery phase. So it's about 4 or 5 weeks in total. We wanted to get to something that we could release and get out into the world pretty quickly. But we've used that time to go out and speak to as many people within the sector as we could, particularly focusing on data scientists or people at energy technology companies who could benefit from better access to energy data. And everyone we spoke to could, had no problem telling us of all the challenges they've come across when trying to access energy data. Lots of things around, like some data scientists said that the machine learning bit was the easy part. It was actually getting the data that was difficult. Not being able to scale machine learning based solutions because the data is not available automatically. And and lots of stuff like that. And I think what we ended up doing was figuring, we had to find a place to start. We were a small team and we wanted to deliver something meaningful. So rather than trying to take on the whole challenge, we try and carve out a subset of that. And to do that, we want to really clarify the problem. So, what we were finding was that data scientists are spending at least 80% of their time collecting, merging, and parsing energy system data rather than actually, doing the interesting bit. A lot said it takes months to get the data they needed, maybe even longer. And the fact of the matter was that most were giving up. And this was data scientists that were familiar with the energy sector, that had worked in the sector for maybe 5, 10, 15 years. So if we want to also attract younger, data scientists coming out of university to work on climate related or energy related challenges, then we really need to lower the barrier to entry. And we grouped the challenges in 4 distinct areas. So there was discoverability, where we saw really low awareness of what data exists and where to find it. Accessibility, so data was held in multiple disparate systems and is heavily protected. Reliability, where data sets are kind of rarely maintained and uptimes aren't guaranteed. And finally, and probably most importantly, usability, where standards are inconsistent and industry APIs were overly complex. So that was where the idea for Weave really came from. We quite early on came to this tagline of getting energy system data with a few lines of code. It was something that a few of the data scientists we spoke to early on mentioned, just this idea of them being in their existing workflow and just being able to pull in really good high quality energy data rather than have to go and spend months searching for it, collecting it, piecing it together. And there were really 3 kind of core components to the value proposition that we wanted to deliver, and that was that it was simplified. So there was a single point of access. People didn't have to go looking all over the internet for the data, and there was documentation that was easy to understand. It was standardized, so people knew what they were looking at and what they were working with. Consistent data structures that were maintained and kept up to date. And finally, it was consolidated. So, particularly the nature of the energy industry, things are often kind of by default disaggregated. So we wanted to consolidate all that data and remove the need for unnecessary merging, parsing, and processing of data. And at a very, very high level, Steve's going to kind of go into this in more detail and cover some of the technical aspects. But how Weave works as a product is we go out and we go and get all of the smart meter data that the DNOs are publishing. So this was kind of something that was really interesting to us, that at the time of the start of the project, there was this large volume of smart meter data that was now being published, but we'd heard from quite a few data scientists that to access that data was difficult. To download it from an open data portal would often crash their machine. So we kind of went out and we pulled all that data from the DNO's platforms, we consolidated it and cleaned it and standardized it, and then stored it in what's called a Parquet or GeoParquet file format. So again, Steve will cover this in more detail, but at a very high level, it's a fast and efficient kind of data format. And we stored that in the cloud, so it was readily available in an AWS S3 bucket. And that was essentially what became Weave. That was the product, that it allowed a data scientist from within their current workflow, within their current environment, whether that's a Jupyter notebook or their kind of VSCO, the development environment, they could interact directly with this vast amount of smart meter data and take a small part of it and play around with it, experiment with it, go and get a little bit more. And that really was the idea. And we started with the idea of can we make that happen with a few lines of code? We ultimately kind of made it possible with 1 line of code, although that is the entire data set there, so you better have some good storage on your machine. But we ultimately did manage to deliver that, so a data scientist can drop a line of code into their current workflow and start interacting and experimenting with massive amounts of smart meter data. And then for a few more lines of code, you can start to do some quite interesting things. So that smart meter data set, it's kind of quite a few of the DNOs are now publishing data, not all of them those. You can see the coverage on that map there, but you're able to, I think this is for an isolated half-hourly period. You can start to map that and color code that demand across the whole of the UK. And I'm sure you could do some pretty interesting things if you did that over different time periods and so on. For a few more lines of code, again, you can start to pull out consumption profiles for individual substations. And quite interestingly, one of the potential blockers we saw at the start of this project, when we started looking into the data itself, was because the data is aggregated at LV feeder level, so that's kind of groups of maybe 10 to 50 houses, we thought potentially some of the detail was going to be lost in the noise. But when we looked into the data, we could see that was really not the case. You know, there's a few substations there in that chart that have been overlaid, and there's massive variation, you know, substation to substation and week to week throughout the data. So we really do believe there's a ton of value in that data, and we want to encourage the the data scientists in the space to kind of really experiment with it and see what they can find. And just to kind of reiterate that point, these are a couple of heat maps that we created to kind of show the variation in the data. So kind of got that's showing the daily profile in a typical week in June 24, I think, as an example for 6 different LV feeders, so 6 different groups of smart meters. And you can see there they've got the really typical profile of kind of low consumption overnight. If you look at that top left one, kicks in about 7 or 8 a.m. during the weekday, a little bit later on a Saturday, and then a little bit later on a Sunday, which is quite interesting. Low consumption during the day, during the weekdays, and then peaking in the evenings, a bit lower on Fridays. You know, it's really interesting what you can see. And then there's some other examples with flatter consumption profiles where, you know, you can see some overnight consumption, perhaps between midnight and 5 a.m. That bottom middle one. So we've been doing some analysis into, like, can we detect EV, areas of the country with higher EV concentrations, and yeah, it's super interesting. Again, we're not data scientists ourselves, so we're not the right people to be dealing with this data, but we really do think that the right people working on this could generate some really interesting insights, because ultimately that's 6 LV feeders. There are hundreds of thousands. It represents millions of smart meters. So some really interesting stuff can be done, I'm sure. So I'm going to hand over to Steve to do a bit more of a technical deep dive, and then I'll come back at the end.
Hi, yes, I'm Steve. I've been the main engineer working on Weave for the Centre for AI and Climate for the project. So yeah, I'm going to do a little bit more kind of technical detail on the solution that we've built. I'll talk about why we made some of the tech decisions that we did, and particularly around how we chose to use this format that John's already talked about, the kind of GeoParquet format, because that's really the key enabler of Weave, basically, of what we've done. So as John said, we went through a lot of iterations trying to understand the problems that users of energy data might be facing, particularly data scientists and machine learning engineers. And part of the issue is that there's lots of different ways that people might want to use the data, because it has quite a lot of different dimensions. So firstly, as John showed, it's energy usage data is temporal. You use energy over time, and generally in the UK, that means it's measured every half an hour, which aligns with our energy systems settlement period, the market settlement period. But it's also geospatial, as you can see on the map, because that energy has to be consumed somewhere. And then finally, it's also connected to the kind of topology of the energy network, so which gives it a kind of a graph structure, which is kind of geospatial, but also kind of different. And these different dimensions made it hard for us to kind of build a perfect system that met everybody's needs. And we experimented with a lot of traditional solutions to that problem, like building different APIs that allowed you to query it in different ways. But they all exhibited a lot of the same problems that John's already talked about, in terms of being difficult to discover or not really meeting that threshold of a couple of lines of code to just get it, and really opening the doors to people. If we go to the next slide, John. So luckily, we had some great feedback from some of the folks on our advisory group. And early on, we were pointed to a pretty similar project that was looking at weather data. And that led us to this analysis-ready cloud optimizer, or ARCO file format, which is kind of a movement, a trend, particularly in climate and weather modeling data, that is trying to make the best use of cloud hosting systems with a new generation of file formats that's designed specifically for them. So designed for kind of, I guess, the primitives that you get from working with the cloud directly, rather than thinking about hard drives or that kind of technology. And the aim here is basically to use the sort of almost infinite scalability of storage systems like Amazon's S3 or Google Cloud Storage, along with these more efficient and flexible file formats that really allow you to get the data as close to the needs of its users as possible. And by closer, I mean closer in terms of the structure and the format. That means you can use them more efficiently, but also just like literally closer in terms of physical location or logical location. So you're putting it in the same cloud that people are trying to do the computation. So they're running their machine learning models in the cloud, putting the data right next to it makes it a lot easier for them to use. Unfortunately for us, smart meter data isn't quite like weather or climate data, so we couldn't just use exactly the same set of tools and move on. But the general idea there definitely applies, and there are some other Arco file formats that do apply really well to smart meter data. So after trialing a few of those with more prototypes, we settled on GeoParquet. If you go to the next slide, John. So GeoParquet, as the name suggests, is a geospatial extension to a file format called Parquet. Parquet is extremely popular. It's been around for quite a while. It's very popular in all sorts of data analysis applications, which means it will be very familiar to a lot of our intended users, and it's very well supported in all of their tools. I'm not going to try and bore you with the details of the image on the right, which is sort of explaining how Parquet files are put together. But suffice to say, yeah, it's a very efficient way of storing lots of tabular data, especially when you might not want to download or process all of it. So you can do clever things to organize it into different sections that make loading the data over a network very quick. And you can provide a separate kind of index or table of contents metadata that would about otherwise kind of huge data sets that you can download really quickly and see what's in them ahead of time. And in that way, a Parquet file is kind of very much like a data catalog, which is kind of takes us right back to the start of what we were tasked to do with Weave. But it's a data catalog that's kind of hyper optimized for machines to read rather than for people to look at. The geo extension part of that is really just a way of fitting geospatial data into that, on sort of adding those capabilities on top of the existing features that Parquet had for numeric or textual data. And in some ways, it's very timely that we were able to work on Weave when we did, because GeoParquet is quite a new extension to the Parquet file format, and it's something that only really became kind of generally available in the tooling maybe 6 months or a year before we started working on the project. Without that, it would have been a much more esoteric option, much more difficult for people to pick up and use. So fundamentally, what we've done with Weave is to collect, standardize all of that data, and that the DNOs, the different DNOs in the UK have been publishing, and then really try and boil it down into these GeoParquet files that make all of the usage patterns we've heard from people both possible and ideally really quick. I think it might have been billed that I'm going to do a demo on this part, but it's quite hard to demo some binary data files. So instead, I've got a few slides, the same kind of slides that John talked over, where I can show a bit more about what's possible with those file formats, and then talk about how we made it work, basically how we put the data into those. So the first one that John talks about already is this kind of temporal querying of data, accessing it by time. So as I said, the data is fundamentally aligned to half-hourly market settlement periods that we have here in the UK. And so it makes sense that people want to query it by those. In this example, we've just pulled out a single half-hour period and put it on a map, because that makes it a very small amount of data that you can look at really quickly. If you were trying to train a machine learning model, you might want at least a whole year's worth of data or more, but the concept is the same, and it's really easy to do with the way that the data is structured. What makes this example particularly fast is that we've actually sorted the whole data set by these timestamps. So you don't need to download it all to get what you want. You can go to that metadata, that index of the file, learn that it's been sorted by timestamp, and be told exactly where in the huge file that small piece of data is that you want. And then you only need to go and get that small piece. So it means a really small amount of data comes over the network, and a really small amount of data ends up in memory on your machine, which makes it really easy to work with. This is a nice idea when we started working on it, and we were playing with a month's worth of data, but now we've got hundreds of gigabytes of data for over a year. It's actually a kind of a necessity, as John says. It's kind of really hard to work with it all in one go, even on a pretty decent powered laptop. If we go to the next slide. The next thing that we wanted to support is people querying the data geospatially. So this is where we think there's real value in the data that's being released, because as well as knowing what energy is being consumed, knowing roughly where that was being consumed can actually unlock all sorts of additional analysis. So it's possible to link this data to things like local authority boundaries or statistical geographies and other kind of interesting geospatial data sets like that. It's important to know that currently in the smart meter data, the locations that you've got are those of secondary substations, essentially the first bit of the energy network infrastructure where you can aggregate and locate that data without identifying someone personally. So it's not an individual property location. And to support querying this, what we've done is basically add additional bounding box data to the Parquet files when we save them with those locations. And we've backfilled a lot of the locations that are missing from some of the DNOs from some of their other open data sources that are available, so that everything is properly located. And then with those bounding boxes, you can do a query like in this code example, where you basically say, I want to see just the data that reflects secondary substations within this rectangular area that I'm interested in. And then again, it kind of has all of those benefits of just loading that specific subset that you're really interested in, not having to deal with all the rest of it. This one isn't quite as quick because we can't fundamentally sort the data in two different ways at the same time, but it still saves a lot of those network bandwidth costs. We think that, yeah, there's a lot of potential in the future to expand these columns a little bit, because things like those area codes and things are things you can really add in and sort of preload a lot of the queries that people might want to do. Finally, then, the other thing that we knew that people would want to do is make use of the data in the context of the electricity grid itself, which we kind of call the grid topology, because you can view the grid as a kind of connected graph where you've got these low-level feeders at the bottom that are then aggregated and connected up to secondary substations and then primary substations and all the way up through the distribution network to grid supply points and the kind of national transmission network. It's really interesting to explore it in that way. This example that John talked about is pulling out just a few days worth of data for one substation and then looking at the low voltage feeders that sort of come out of that and go to a number of homes each. And it gives a nice visual representation of how they all vary. But there's no reason you can't start to aggregate that up higher and higher and really look at patterns across different parts of the grid, which, as Pete said, starts to help unlock some of those use cases for grid planning and analyzing capacity of the networks and that kind of thing. The main way that we've supported this query pattern is by coming up with a standardized identification scheme for those feeders and substations. So you can always find the same part of the grid that you're interested in across every day, a week, month, whatever. But again, it would be really easy to continue this work and continue that identification further up and start putting in identifiers for the primaries and bulk supply points and so on above those substations. And yeah, that's where we're at. I think I'm going to hand back to John now.
Oh, thanks, Steve. And yeah, just to finish off, then I kind of want to touch on some kind of real-world use cases for Weave, and I'll kind of talk about how to get involved as well. But I think in full transparency, and the kind of the elephant in the room throughout this whole project has been the real-world application and the practical use cases for this data. The DNOs are kind of very aware of this. Whenever we've spoken to them, they've asked us about how people are using the data and what are the use cases, because it's a big undertaking for them to collect and store and make this data available. And it's been really interesting that we've spent a lot of time talking about this. I think everybody you speak to feels like this data has to be useful. Energy demand is so fundamental, and being able to get that kind of high resolution view of that is key. But yeah, there isn't any use cases kind of screaming out to us. And I think we've kind of come to the conclusion that there's probably a bit of a chicken and egg problem where this data wasn't available and was, well, firstly not available and then not accessible. People haven't quite got to those use cases yet. Perhaps there aren't enough data scientists in the energy sector, working on this data and experimenting with it. So we're really interested to kind of push that forward and hear any thoughts on that, because ultimately that's what matters here. But we still got a bit of an open question around that. Having said that, we did have some really interesting conversations, and I wanted to touch on a few of those. So we spoke to a data scientist at Ali, who are a community battery developer. So they were looking to kind of develop the business case for community scale batteries, and to model energy consumption at that kind of level, they were just using really high level abstractions. So having access to that data that actually turned out at LV feeder level was a really perfect level for them. Gave them actual real data that they could use, and they could see how that varied across the country within different types of kind of housing and demographics and social aspects. So that was really interesting. Maytech, who are a digital services consultancy, we didn't end up doing like anything specifically with them, but we had a lot of conversations with them and the projects that they work on. So they do a lot of work with local authorities who are looking at different areas of their regions and looking at concepts like energy poverty and where energy costs are high. Does energy consumption and energy efficiency vary with different housing stock. You know, do old buildings cost more than and then the one that came out of quite a left field for us was we had someone from Columbia University in the States reach out. So a climate tech club, and they were looking to run a hackathon and were desperately looking for some interesting energy data that they could use for their hackathon, and were, you know, coming up against the same challenges that a lot of people did, that it just wasn't easy to access. So they asked if they could use our data set in their hackathon, which they did. So that was pretty cool. And it's probably things here is that if you're a data scientist and you're looking to build a model, you want access to as large a data set as possible. And that's really, and that's what we were trying to do with Weave, and that's why it kind of really appealed to that use case there. So skip slide. And then, yeah, finally, in terms of how could someone get involved, how could you contribute or work with Weave? So there are three ways really. First is to use the Weave data set. That's fundamentally what we want people to do, is start experimenting with it. Like I said, it's a massive data set, very, very complex, but we really do think there's a lot of value in there. We've barely scratched the surface in what we're able to do. We're data scientists ourselves, but every time we look at it, we find something really interesting. So I'm sure with a lot of data scientists working and experimenting with data, there'll be some really powerful insights in there. You can also contribute to the project, so it's open source on GitHub. You can find that through the website. I can see some questions around like different data sets that could be used to add context to the Weave data set, and we really believe that's kind of the next stage of it. And the way to make it more powerful is to add some context to the smart meter data, whether that's concentration of smart versus dumb meters, or smart versus smart meters that are actually communicating and understanding what the
Steve, John, you're breaking up occasionally, so I think I'm going to take this opportunity to jump to questions on the Weave platform, if that's all right. Don't know if you can still hear us. You seem to have frozen. Steve Day, are you around? Can you still hear us?
Yeah, I am here. So yeah,
excellent. Okay, well, in that case, I think we will jump onto some questions. So lots of questions in the chat. Thank you very much for those, everyone. But there is a more general Q&A at the end of the session, so I may take chair's prerogative and move a couple of those to the general section. So Robbie's question on legalities of open data, I think I might bump that one till after the panel, Robbie, but we'll definitely come to that. Ravi's asked you whether other parameters like reactive current are measured and made available in Weave, Steve?
Yes, there is reactive power. We're not currently making it available, but it would be a very trivial thing to add if it was of interest. It's actually the first time we've heard someone who is interested in that, which is why it's not in there. So I'd love to maybe hear in the comments like why that's interesting, why that's useful, what kind of use cases you'd have for that. But yes, it's reactive power. So not, I think maybe I can cover a couple of questions at the same time on a similar thing. That we don't have voltages or current, but we do have watt hours. Basically, we have measures of consumption, both reactive and whatever the opposite of reactive is that we're currently putting out.
Real, yeah, that's fine. And so I think we might combine the next two as well. So there's a question around metadata. So do you capture spatial details, aggregated demography of customers in the region, and concentration of LCTs, solar, EV, and then someone else has asked about microgen and batteries.
So we don't capture those specifically at the moment, but those kinds of data sets are available from the DNOs in ways that you could link those to. Generally speaking, not at the exact same level of aggregation. So you need to, I think particularly for LCTs and those kinds of things, you need to look up slightly. They might tell you how many are connected to the nearest primary substation. So you could aggregate up all of the secondaries below that and get a comparative thing. The only other metadata that were available that would make sense for this specific data is things like what percentage of smart meters are there connected to that secondary substation, so that you can put in context the numbers that you're seeing.
Yeah, and related to that, I'll jump in, and I know that that's certainly something that user groups have been taking back to DNOs directly. And Eric has asked a question that almost as if by plan leads on from this. So what penetration of smart meters do you need in an area before you can draw reliable insight? Do you want to comment on that?
I don't know. So statistically, I think someone has asked the question that there is a hard limit of if there's not at least 5 meters connected to the feeder, that data is not reported from the sort of point of view of not making it personally identifiable. So there will be gaps in the data set from that perspective. Statistically, I guess it's a question for a statistician. How many do you need to give it otherwise? But yeah, you need to use that contextual data to make a judgment on that.
Okay, yeah, thanks very much. And yeah, I think that's a very difficult question, and also depends whether you can actually get that data reliably. And then we've got a few more questions on disaggregation. So is the data disaggregated by energy service? So energy used for heating, mobility, and general electrical loads?
No, it's purely, yeah, it's what a normal household smart meter would report, basically a single number of watt hours consumed, and then those are added up effectively just underneath that feeder.
Great stuff. A question, I think, which is maybe fairly quick, is how do you map assets to different topographical levels? So
the fundamental work of mapping a specific smart meter to a feeder to a secondary substation has been undertaken by the DNOs. They have that knowledge internally. When they then give those identifiers for the feeders, the secondary substations, and so on, we can then use those with other data sets that they publish. It's quite common for DNOs to publish bounding box, for example, of the area served by a primary substation, which includes the secondaries, or in some cases, I think the identifiers are a kind of hierarchical identifier. So the ID for a feeder is the feeder's number plus the secondary's number plus the primary's number, and so on. So you can take it up the chain if you want to from that perspective. Great.
I think we've got time for one more in your specific Q&A, and then I'll move it on to the panel. So I'm going to amalgamate the 2 questions really here about data quality. So someone highlights quality control seems like a big challenge, and they've highlighted some NGED data actually. So there might be someone on the call who can talk about that directly in a moment. But there's a pretty big maximum likely due to spurious values. And then Marco underneath that has asked what the main challenges you face during data formatting, data quality and enrichment.
Yes, so on those very big maximums specifically, they're actually, I think it's a very recent discovery that we've had through talking to a DNO, but there are cases where a smart meter itself reports a very specific number of watt hours to denote an error. So rather than it being a null or whatever, it's in the millions of kilowatt hours, and they have not been filtering those out. They're trying to present the data as raw as possible. So there are cases where you're seeing gigawatts of consumption in a particular half hour, but it's actually because they've essentially added up these error values. So it's something that we would like to do to try and reverse those back out basically, and see when they exist, which should be kind of feasible to do. Beyond that, then I think there probably are other issues, and this is one of the cases for making it so easy for people to look at it. I think in the sense that it's actually very difficult in its raw state to do that kind of analysis and to look at so easily. But yes, that is a difficult thing. Other challenges, I think, in terms of effort that we put into it, where, for example, locations of substations weren't published in the dataset but are available elsewhere, that proved quite time consuming just to find all of the right data sets, be confident that the locations are accurate, that we've got the locations of all of the substations that are mentioned in the data sets, that kind of thing. That's probably the biggest challenge. Yeah, the rest of it is just, I suppose, a case of understanding the data as well. That's one thing we've discovered. A lot of these data sets they're in a standardized format, an agreed format that was agreed by the DNOs. But I think from what we've learned from experiences, the agreement they all took away was slightly different in their interpretation. So different columns are used for slightly different meanings of identifier, for example, and that kind of thing, which we've had to work around. But
great stuff. Thanks, Stephen. I can see there's still a couple more questions in the comments, but you may be able to get to them in the comments, or we might be able to return later. I'm going to move us on now, though, to our panel, because we have a really good list of people to talk to us more widely about the value of open and smart data. So if I can ask the panelists to please put their cameras on. Thank you very much. So yeah, just to briefly introduce the panel, we have Charlie Clark, who is the Principal Policy Expert for the Energy Systems Digitalization team in Ofgem, to give us a regulator's perspective on what we're talking about. We have Grant Wilson from Birmingham University, recently appointed as the co-director of the Birmingham Energy Institute and chair of the Gas Advisory Council for NESO. From National Grid Electricity Distribution, we have two people. Thank you very much for joining us. We have Rachel Prosser, who's the National Systems Manager, and Daniel Clements, who's an Innovation Engineer in the Future Capability team. And then finally, we have Paul Pouget, who's the lead machine learning engineer at Kaluza, who will give us more of an innovator and data user perspective. So thank you all for joining us. I'm looking forward to a lively panel session and some really interesting perspectives. I wonder if I can start with you, Charlie, actually, and look at the regulatory perspective, starting from the top in some ways. So in your view, how can regulators best foster an environment where tools like Weave can be effectively developed, and how can they be nurtured and integrated into the energy system from a regulator's point of view?
Thanks very much, Richard, and thank you very much for having me here, folks. I will slightly reframe the question, if I might, and just say in terms of from the top. I wouldn't like to think the regulator is the top anywhere. I would say we are alongside, possibly having more of a kind of policing and management role as opposed to being from the top. I don't know who would be the top of the energy sector, but I think in this context, it'd be transmission organizations and DNOs as the flow of data comes down from them. However, very cheering to hear in the discussion the levels at subfeeder when we're talking about 5 MPANs to 50 MPANs to 10 MPANs and all this discussion about what was the right number, because with data best practice, my current work stream, we set those levels in the decision in August of 2023, where we obliged all transmission companies to publish this data and take a presumption of openness. Data best practices, 11 principles talking about interoperability, ways to use things, setting metadata requirements such as Dublin core metadata, and setting licensing requirements so those taking data from the DNOs don't have to go through 32 different lawyers and then make sure that the data sets are interoperable between each different one. We tried to set these as open and as principle based as we can, underpinned by the keystone principle of presumed open. If data can be opened, if it can be triaged without hitting CNI or critical national infrastructure risks, and without the danger of exposing PII, personally identifiable information, as why we're at aggregated data in order to require the anonymity, that's where we can do best. Where the regulator can't, I don't think, is create these products or start trying to set the parameters of where it can be, get into micromanaging the actual data science, because it's out with our aegis. I think it's out with our abilities as well. I'm not a data scientist. We've got certainly some in Ofgem, but we don't have the capacity and the innovation that people like the kind of Weave team and ESC and everyone else can provide. So where I see our place is to try and set as much of this data open and set as much of it out into the world, and then see what is created by cleverer people than I.
Great stuff, and yeah, point very much taken on my flippant use of the top there, and thank you for correcting that.
Industry get very excited if I call myself on the top. It's not a great look.
That's really interesting, and it's really interesting to hear you refer to the presumed open principles. I'm interested in thinking about what the impact of that has been from your perspective, how successful you think it's been, and maybe any lessons learned from trying to do that, and indeed what might be the next steps.
I think with that, in terms of, I'll take reverse for that one.
No problem.
It's not finished by any manner of means. Data best practice is an ongoing process. We've looked at it through the network companies as the largest priority data sets. I'm currently expanding into codes, where all of the many and various heterogeneous industry codes that sit underneath our license conditions will have data best practice as an obligation. CCUS, carbon capture, usage and storage, currently have that as part of their license conditions. I'll be looking into suppliers, heat networks, and eventually aiming to get to generators and suppliers and covering every licensed activity within the energy sector. The ideal dream eventually, when I started this off, the dream was to have a common data taxonomy, common data glossary for the entirety of the energy sector. I strongly doubt that's achievable within my lifetime, and I strongly doubt it's really required, to be perfectly honest, because there are things being worked on, kind of extract, transform, load nodes. There's many APIs, and there's a degree of standardizing, where as long as the data is in roughly the right shape and format, it can be pulled into tools like Weave, things like the proposed DSI or data sharing infrastructure, and then put into a standardized format there. Requiring every company to use the same taxonomy, the same glossary, even the same metadata, tends to create greater IT expenditure than the benefits come out from it. So that's one of the ongoing points we're going from there. And there's your lessons learned there. Focusing too much and making sure everyone's using exactly the same glossary, exactly the same taxonomy, may have been not necessarily unwise, but unambitious would be the way I'd possibly put it. In terms of how well it's going, I'm better placed to hear it from people here, to be perfectly honest. I'm working at a regulator level, and people who are regulated don't generally tend to tell me when things are going badly. They're happy when things are going well, but when things are going badly, perhaps data sets are not being triaged as quickly or as easily as they could be. I'm commonly the last to find out unless I actively go hunting for it. And I put out a kind of open call for the innovators and the people who use data on this. If you've tried to get hold of something from a DNO, from a transmission from NESO, and you haven't been able to get it, don't necessarily come to us, come to discussions. We can see if it's something that can be triaged openly. I'm not saying, the regulator will automatically open up everything. There are quite sensible intellectual property, CNI, PII reasons not to open data sets, but we're running with a presumption of open where we can. So I would like to hear if there are cases where it hasn't gone as well as it could do. Do let me know, and we'll see what we can do to kind of shake things loose to open up data for the benefit of the whole system.
Thanks very much, Charlie. Yeah, on that note, thinking about how people use the data, and I will be coming back to how people provide the data as well in a moment for our colleagues from NGED, but jump into the users. Paul, maybe you could talk to us a little bit about how Kaluza uses smart data, and maybe particularly if and how you use open smart data.
Yeah, no problem. So yeah, as a company, we use a lot of data and a lot of smart data. So one of our core products is to control residential flexibility devices to, on one side, provide value for the customers, and on the other side, create value for the grid by using that flexibility. So for that, we need a lot of device data. So we're connecting to many devices, market data, and also customer preferences or requirements. And we're looking to enrich our algorithms with as much data as we can find. So this can mean some open data. So currently we're not using with data as part of our core algorithms, because there's no markets that run on with data specifically, like capacity market or stuff like that. However, I've been using with data for more like innovation projects, and one of the things I've tried to do with it is to detect electric vehicles in that with data signals, and with like during an innovation project with number 10, like it was a hackathon, and it's been a great experience overall. So yeah, maybe derailing a bit the question there, but that's that's where like we've ended up using with data currently. But we see the use of open data as a company as potentially great for enriching our customer experience and bringing that sort of network side data to the customer in a comprehensive way to help them, to tell them the story of how we're using the assets and what benefits it brings to the grid. So I think that's where for us, we see a lot of value for this kind of data sets.
Great, thanks very much. And I'm going to bring Grant in at the same time with a similar question, I think, if that's all right. So Grant, from your point of view as an energy researcher, can you talk about the open data sets or the smart data sets that you use, and maybe take us to some of the main barriers you might hit when you're doing research? And if there was one golden ticket data set that you could unlock, what would it be?
Thank you, Richard. Quite an expansive wish list, actually, in terms of that. So I'll just share Charlie's thoughts in terms of, thank you very much for allowing me to sort of express some thoughts around this. It really sort of resonated in terms of the challenges, the 80% of time in terms of pulling data sets together. It's not always the quality, it's just the different interpretation, as I think somebody mentioned, of they say the standards. Really interesting as well to hear Charlie's view on, you know, the benefit, the trade-off. There's always trade-offs, you know, the trade-off between trying to get people to standardize versus, you know, being able to do things on the fly as well. I would actually share that in most part from Charlie's perspective, is rather than trying to have everything standardized, because I don't think it's ever going to happen. But having said that, I think there is a real benefit to having a standardized set of unique identifiers, whatever that might be, so that, you know, books, for example, if you want to publish a book, you get a ISBN number from a data registration body, which means that book is only ever going to be that particular book and nothing else. So a lot of the stuff we deal with, we know, I'm sure many people on the call are very used to working with, say, postcodes, but if you want a geographical representation of a particular postcode, you're then into licensing agreements, not the postcode itself, but the actual geographical boundary of that postcode, if you want to then share and make that more available. As a wish list, I think, actually, I mean, there's a few, but I think I would temper it. And actually, my biggest wish would just be that the unique identifiers, there's the body or bodies responsible for the creation of unique identifiers. And they are genuinely, you know, funded to be able to carry that role out competently and over a long period of time. I mean, just when we get into details around building footprints effectively, I mean, it's one element, but even unique identifiers for buildings in United Kingdom, there are these things called unique property reference numbers, which are more or less a unique identifier. They're kind of most of the way there, but we've done analysis on it. They tend to break down a little bit for industrial and commercial type buildings. Domestic, there's a very good coverage. But even stuff like, you know, the areas, the geographical areas, when you start digging around, I've put a bit in the chat. It's a bit like pubs in the United Kingdom, if you want to see how many different pubs are called the Railway Pub or the King's Arms or something like this, actually, you have primary level substations which are called under text, not their unique identifier code, but they're the same, even within particular sort of DNOs actually as well. So I think just finishing off around that, unique identifiers, having a central body that was responsible for them, I think would be really, really helpful. And then when people add other value to data and then pull it all together, do whatever they are looking to do, they know that they're talking about the same thing, whatever that thing happens to be. It's just that's the same thing. And therefore, I think that's really helpful, because actually some of the times we get into analysis and we're not 100% sure if actually people are talking about the same thing. We think they are, but we're not 100%.
Yeah, that's really interesting, Grant. Thanks, though. Then, yes, you very much subverted my question, which is as I would expect any good academic to do. So it's not a data set; it's a set of identifiers. Charlie, I can see you want to jump back in.
I absolutely do. If only to give a round of applause to Grant's point there. Having UPRN clearly identifiable would be such a time saver and a space saver, and just basically force multiply almost every bit of data work, particularly when we come up to the kind of higher levels of more acronyms. I do apologize, but for the energy sector, you're using for electricity an MPAN, a meter point administration number, or an MPRN, meter point registration number for gas. For water, it's an SPID, and for telecom, it's a further one. Having each one of these four numbers linked to a single UPRN then means we have a universal register for each one of these. That doesn't exist right now. There's lots of people trying to build it with various cross-sector approaches, but that makes almost every aspect of, someone mentioned poverty reduction and fuel poverty in the chat earlier, every aspect of fuel poverty becomes easier when you can link all those data sets to a single address. So yes, I thoroughly support that wish list.
Yeah. And I'll cheekily, as a moderator, add my weight to that too. It will be a great thing. So just to now bring in our colleagues from National Grid as the providing the fundamentals of this whole thing, really. So providing the data that underpins Weave and many other data sets for that matter. I wondered, and I'm not sure, Rachel or Daniel, who's best placed to answer some of these, so please do jump in or give us your individual views. But I wondered if you could start off by telling us a bit about your data strategy. So how do you decide which data sets you can share, which you should share, what data sets you collect, for example, and how is that driven? Is that externally driven or internally driven from within National Grid?
Yeah, I can pick that up. So obviously the consumption data, that's externally motivated. So we are obligated to aggregate and publish that on our open data portals. But otherwise, our strategy is based around the principles of responsible data use. So we want to maximize the value for our customers. We want to align with regulatory commitments, and we'll prioritize the data sets based on business criticality. So we're looking at the flexibility of our network, the capacity, the areas required for growth. And we want to make sure that we are, providing assistance where we can to those who come to us with their queries, their requirements. So we want to make sure that we have that capacity to work alongside others, as long as that data has been assessed for quality, for sensitivity, relevance to the project. We don't want to go violating any of the data privacy plan that we've got in place. And so we've got sort of internal governance structures that ensure that we are compliant with that. I don't know if Dan wants to add anything.
No, I think that was pretty spot on. I would say that I think that the balance between external and internal drivers is shifting. I think historically internal use cases dominated what we would present to everybody, but it seems that external demand is growing rapidly now, especially from like innovators, academia, and partners that we're working with on decarbonisation and flexibility. So we are starting. It's starting to shift a bit more towards external factors that are kind of the shift for what we're presenting to everybody, really.
Yeah, thanks. Yeah, that's an interesting point as that beds in, and I guess that intersects with the presumed open principles flowing down that everyone's now looking for some more data. So I suppose sort of reversing the perspective a little bit, and again staying with you Rachel and Daniel, just for one more question, if I may. Is there anything that you would like to see more of from innovators? So is there something that you would like to see innovators doing with your data that isn't happening just yet?
Yeah, absolutely. I think we undertook a stakeholder engagement piece earlier in, not this year, last year. And I think one of the big flags that we found was that people aren't aware that we may publish the data set which we currently do. So I think there's a good piece about two-way engagement to be undertaken. So we reach out, but simultaneously we would like to see innovators share feedback with us directly, or reach out to us and make use cases. Tell us about your successes that you've had with certain data sets. Maybe it's transferable to something else. We definitely would welcome collaboration, pilot schemes. We're very much open to trialing anything across the organization that we can. I think we have certain pots of data that we're not 100% sure what we can do with in its entirety. We know how we can tailor it to our network, and we can ensure that we provide the best service that we can to our customers directly utilizing that data, but that's not its complete use case.
Great stuff. Thank you. And I'm going to use that as a nice segue into to ask Grant and Paul, I think, to maybe comment on that direction. So, are there things that the innovators and academia can contribute to the open science space? Are there ways in which the increased availability of data can shape the work that you do, and also are there ways that you could feed that back into the DNOs? Do you want to go first, Grant? I think you've come off mute.
Sorry, it wasn't the presumption to do so, but I think there certainly are. I mean, there's a kind of privileged position, I guess, that academia does have in terms of providing maybe a more sort of neutral view on things, if such a sort of unbiased opinion around things, notwithstanding, I guess we all do have some bias to bring with us. But just I guess making the case, or continuing to make the case about the benefits to the wider ecosystem, about the the acceleration to net zero. We are without a doubt moving into a very, very different realm where data is a massive transformative issue. So we just need to keep making the point, identifying use cases. Potentially academia has a role to play there, but supporting startups, supporting innovators to do that, I think is another role. But yeah, I think just continuing to make the case and to maybe help to pull through new knowledge or working with particular data in some sense can be useful as well. But increasingly, I kind of think there's, for the data to have a historical, the problem with academia, as many people will know, is the kind of project by project basis for its funding. And therefore it's not, without its challenges, particularly for longer lived data sets and for things, it needs to find a home outside of project-based funding. But I think, look, that's not, it's not just the case with academia, that's the case with, Cake and others as well, and we.
Yeah. Thanks, Grant. That's great. Oh, Charlie wants to jump in, and then Paul, I'll come back to you in a moment. Go on, Charlie.
I'll be as quick as I humanly can because I want to avoid monopolising, but I think building off what Grant and Rachel said about use cases and the concept of use cases in general, there's a real risk to my mind, and this is borders on an ideological point, that a focus on use cases tends to be backwards looking, and it tends to an extent, restrict what can be built from the future on the basis of what has been built in the past. The analogy I always use is if your first use case is a motorcycle, you'll build a road this wide, and your next use case is a truck, then you're starting from scratch again. But that was demonstrated with open banking. When open banking went through that seismic shift post 2008 financial crisis, the use cases were switching bank accounts. The use cases are what was understood at the time. What's been built as a result of that, as a result of innovators, has been things like Monzo, has been completely different financial paradigms, and they couldn't have been envisaged at the time. The mindset simply wasn't there because the idea of the growth didn't exist. And that's why certainly with data best practice, I've put it as it doesn't focus on use cases, doesn't focus on what has been there before. It's as open and as principles based as possible. Get any data that can be safely opened, open, and then things will be built for an element of experimentation without expectation, which comes very much back to academia and the dream of the kind of blue sky research, because that's where genuine innovative leaps get made.
Thanks, Charlie. And on that note, I'll open back up to Paul just for the final word before we go to questions and ask therefore, and it kind of neatly segues on. What's holding you back at the moment? So is there anything, what elements of data and digital landscape are holding back widespread adoption of open smart data?
So I think quality, I mean, it's more like completeness and timeliness, I think, are the two key elements which are super useful, especially when dealing with online devices such as EVs, home batteries and stuff like that. People expect, because we're reporting to them the state of their EVs, the state of their battery, people expect the sort of same speed for the data to come in from the grid as well, and from the use cases we're looking for with the EV flexible devices, with our EV or other flexible devices. I guess to come back to your other questions on what you can feed back, one thing as a machine learning practitioner that I found is that as soon as you run a machine learning algorithm on a data set, you uncover lots of problems with the data itself or the devices collecting that data that you didn't know about before. So I think it's quite key to get people to use that data, because you will naturally improve the quality of that data. You will find the small problems and then like slowly fix them to improve that data quality overall. So I think it's quite key to have like that usage, and as users or innovators, we can feed that back because we'll see them by running machine learning algorithms on them.
Thanks, Paul. That's a really interesting, that's a really interesting point to finish on. I think kind of closing that loop, and the data goes right through the algorithm and back again. You can say there's a problem with the real low level collection. That's been brilliant, and I want to thank you all on the panel for contributing. We've got about, I've squeezed the quick Q&A slightly because it was an interesting discussion, but we've got about 15 minutes left for Q&As, and I'm going to try and pick some things up from the chat first, but if people have other points they want to make, please do drop them in the chat at the bottom and we'll get to them. There's 2 or 3 questions here, and perhaps someone from CAIC could jump back on camera as well, Pete or Steve maybe. And there's 2 or 3 questions around licensing. There's a general question from Robbie at the top about how we best grasp the interconnected nature of licenses if we're bringing data sets together. A specific question on what the licensing for using Weave tool and data is specifically. And then there's also a question about, does presumed open have an impact on what licenses can be used on the data? Who wants to go first? Steve's going first.
I can answer from a general perspective, and I guess I should caveat with the thing, I'm not a lawyer. I have linked to our FAQs where we've put some more detailed stuff on this that we have kind of fact checked and whatnot. Generally speaking, the data that Weave is releasing is all released under the Open Government License or a DNO's version of it, which has the basic same conditions. Often they are labeled as NGED's, I see some shaking heads, but they are labeled as NGED's Open Data License, which then says this derives from the Open Government License. So yeah, in general, basically give some attribution and you'll find you can use it for whatever you like is the general restriction there. I don't know on some of the other questions, but everything that we've used, we have made certain, yeah, we're not access to or getting privy to anything that's more restrictively licensed than that anyway.
Okay. Charlie, do you want to jump in from a regulator's point of view?
Very briefly, because I actually wrote the decision on this one, which was under data best practice, it should be licensed under Open Government License or Creative Commons License version 3 or version 4 or whatever is the most up-to-date version respectively. And there's a line in there that we, DNOs, transmission organizations, etc., can't deviate from those licenses. They can't add their own top spin on that. It is the verbatim text of OGL or CCL respectively, because we ended up with an almost split decision between all of the network companies whether they used OGL or CCL. So we've gone for dual licensing as long as there's no change, addition or amendment to either of those license frameworks to make sure they're open.
Okay, thank you very much. Robbie, I'll give you the right to jump in if you want to see. Has that answered your question, or is there another element you want to put? That's fine. Okay, that's fine in the chat. Great stuff. Okay, there's a couple of questions points here, which I'll form into a question from Simon Elam. So talking about collaborations, really, I think, and use cases that might combine Weave feeder level data with the SERL, that's the Smart Energy Research Lab Observatory household level data. I guess the question form of that would be, are you guys open to further collaborations?
Yeah, I mean, I suppose the short answer to that is the data is there and available, so feel free to use it. In that sense, I don't know what the kind of the details of the SERL data, how easy it would be to link and combine it, whether it's specific households data that you might be looking at, or whether you'd have something that would be directly comparable to a feeder level aggregation of data.
Good stuff. Paul, do you want to jump in?
Yeah, so I mean, one thing we did during our hackathon was to use random combination of the cell data to create sort of low feeder smart meter data, like fake low feeder smart meter data, where we knew the number of EVs on it. And this allowed us to create a very nice training data set that we could then run on the Weave data in order to measure number of EVs. So like these two data sets are very sort of good in terms of combining themselves naturally, because you can use the cell data, or also like there's a data set somewhere of synthetic smart meter data. So you can use those to sort of recreate with, low voltage smart meter feeds by aggregating 5 to 50 of them and use that as training sets, because then you know what devices are behind those meters. So you can sort of start training some disaggregation algorithms or that sort of stuff.
Thanks, Paul. That's great. And then one issue that's come up in the data set, I think, in the the chat, I think that maybe could be explored in the Q&A is what happens, thinking about the smart meter data set in particular, what happens when the aggregation changes? This might be a question mainly to National Grid colleagues, I guess. So if a smart meter becomes activated on a feeder that had previous aggregation, and then you add another one into the aggregation, or one for some reason drops out, how's that handled?
Yeah, no, I can pick that up. You'll have to forgive me because I'm not the expert in the aggregation here, but I will go with my knowledge. So we aggregate if we meet the privacy minimum at that point in time. And then, so for instance, if only 2 reads are received, despite smart reads being sent, and there's less than 5 on the feeder, we're not taking that. For some data sets, it can result in a missing period of the half-hourly read in the aggregation. So for instance, reads up to and including 2 a.m. might be there, but there's not enough devices to aggregate at 2:30. There might be a missing half-hourly period. But again, it's aggregated to those levels.
Okay, thanks, Rachel. A somewhat a maybe provocative question just popped up in the chat, Steve, so I'm going to put you on the spot here. So is aggregated smart data available in Weave from all of the DNOs or only some? And I'm gonna augment it a bit. And if it is only some, what could we do to encourage more data provision?
Yeah, so it is currently only some. And that's both on our part and on the part of the DNOs. We haven't aggregated every single data file that's available. Some are only available, they've only released, say, 1 month's worth of data as a trial, as they're working out their internal systems to release it. So we haven't gone to the effort yet of sort of integrating that prototype, because we're awaiting the fully featured kind of production version of it, which might look different. But I believe, yeah, there are also at least 1 or 2 DNOs who haven't yet done the work to release that data, I think. And I guess, like, fundamentally, as someone said, it's a license obligation, I believe, for them to publish it. So I'm sure we can do something, but there might also be folks on the call who have bigger levers to pull to make that happen.
Yeah, thanks, Steve. Yes, I guess. Oh, go on, Rachel. You jump in.
No, it was just going to highlight, yes, it is a license obligation. And there are DNOs that obviously have different data capacities in how many smart meters we can draw from as well. So NGED obviously represents 4 of the MPIDs across the country, and our penetration is currently sat at 63% of the smart meters. So I guess we are quite a wide representation. I just wanted to highlight why we were hopefully on board.
Good stuff. Yeah, and I suppose from my curiosity, Steve, and from the CAIC and the project overall, have you done much engaging directly with DNOs, or is it actually done pretty much through the digital landscape and just looking at what they've put out there?
So very much initially was that, looking at what's put out there and what data is available through their open data portals and DNO's documentation. Since publishing our kind of initial prototypes and working on things, we did use the feedback mechanisms that DNOs have to sort of share those use cases, share that we were using the data. And as a result, we've been invited to collaborate with quite a few. So we have worked a range from presenting, talking to folks, to having kind of monthly calls where we present a list of issues and have had folks helping us understand the data and work out the bugs and that kind of thing. So yeah, we've seen some really great engagement actually from some of the DNOs when we've pointed out issues like some of the things that folks are raising when they've tried to use it to help us figure those things out.
Yeah, thank you. Okay, Grant, sneak one in right at the end. Can you double check if industrial and commercial demand is available via the smart meter data sets? or not?
No, I think I'm right in saying it's domestic only.
Smart meters are domestic only. Advanced meters for industrial and commercial, I believe.
Yeah, that's my understanding too. Well, I'm conscious of time, and we're slated to finish at 3:30. So I just wanted to take a couple of minutes at the end just to say thank you very much to everyone who's joined. It made for a really interesting webinar. Especially thank you to all of our speakers and our panel. It's been really nice to get that perspective from across the spectrum, not from top to bottom, Charlie, but from across the spectrum of stakeholders. And just speaking from my own point of view, I think a lot of what's been said has chimed. I think particularly when John highlighted how much time and effort can sometimes be expended in cleaning data and pulling it together and using it for analysis and research, and any initiatives to kind of help with that are always very welcome. As someone used the phrase to me as we were starting off the Smart Energy Data Service, that smart energy data is everywhere and yet it's nowhere. And it's a bit of a trite statement, but in some ways is true, that there's so much to do to get it together at times that I certainly welcome any initiatives to bring that together. So yes, on that note, thank you very much to everyone again, and we shall sign off. Thanks very much.
Thanks so much for having us. Thanks, Richard.
Thanks all.
Bye.
Thank you.
Thank you all.
Thank you.
Well,
Thanks, everyone.